Welcome everyone to the AI Research Roundup. I'm your host Alex, and today we're diving into some fascinating AI research. We'll be looking at a paper titled Perception-R1, Pioneering Perception Policy with Reinforcement Learning. This work explores using reinforcement learning, or RL, in the post-training phase for multimodal large language models, specifically focusing on improving their visual perception abilities. They found that simply adding RL doesn't always help. It really depends on the task's perceptual complexity and how you design the rewards. Based on this, they propose a new framework called Perception-R1, which shows some pretty impressive results on various perception tasks. Okay, so Figure 1 here gives us a nice visual overview of this Perception-R1 framework. You see an image, in this case flamingos, and a prompt like, how many flamingos are in the image, getting fed into the multimodal LLM. The model then generates several possible answers. These are called rollouts. What's really key is the next step, the reward modeling. It compares these different answers against the actual ground truth, which here says there are 11 flamingos. For tasks like counting, it uses something called bipartite matching to figure out which predicted flamingo corresponds to which real one before calculating the reward. This reward signal then feeds into the GRPO algorithm to update the model. It's essentially learning from its mistakes based on this specific visual feedback. Building on that idea, Figure 3 gives us a concrete look at the visual counting task in action, similar to the flamingo example we saw in the overview. Here, the input is an image with several birds. The question asks for all the bounding boxes. What's shown as output is how Perception-R1 identifies each bird with a red box. And importantly, it also generates the coordinates for each box textually, followed by the final count, which is 9 in this case. This ties back to that multi-subject reward matching we talked about, figuring out which predicted box corresponds to which actual bird to calculate the reward. So we saw counting. Now Figure 4 shifts gears a bit to show optical character recognition, or OCR. The input here is an image of a magazine page, and the model is asked to basically read it. You can see the output is the transcribed text from that page. So instead of coordinates and counts like before, the model's output is purely text. The reward signal in this case would measure how close this generated text is to the actual text on the page, using maybe edit distance to guide the learning. Okay, moving on. Figure 6 shows us general object detection. Like the counting example, the model outputs bounding boxes and their coordinates. What's new here, though, is that it also assigns a label to each box. You see person, laptop, cell phone listed alongside the coordinates. So that multi-subject reward matching we talked about, well, it now needs to consider both the box location and the label accuracy when calculating the reward. Alright, so Figure 5 demonstrates yet another task, visual grounding. The input is again an image and a question, but notice the question is more specific. Output the bounding box of the woman holding a child. So, unlike the general object detection we saw before, where it found multiple objects, here the goal is to locate one specific object described in the text. The output shows Perception-R1 successfully drawing a box around just that woman and child, and providing the coordinates. The reward here would be based on how accurately this single box matches the described target. So, across all these different examples, counting, OCR, object detection, visual grounding, what's really striking about Perception-R1 is how it tackles these diverse perception tasks using a single reinforcement learning framework. Relying on that clever reward matching system we discussed to learn effectively. This really pushes the boundaries on how we think about training perception models, moving towards more unified and potentially more general AI systems. Well, that's all the time we have for today. Thanks for tuning in to the AI Research Roundup. I'm your host, Alex.